All right. Now, the next question I wanted to ask is we also look at it from a perspective of sustainability, for example, So, again, even if we consider it as fuel agnostic, whether we go with a conventional fuel or a renewable fuel, but how would you say that steam actually impacts on the sustainability aspect for any process plant? Okay, what areas would it contribute to specifically? I would love to have your take on it.
So if you look at sustainability, I would say that let's try to define steam in the context of SDG, which is Sustainable Development Goal. So if we look at a Sustainable Development Goal and the role of steam, I would say that there is one important SDG which is very crucial for us to understand. Responsible consumption and production is one of the SDGs which are very crucial.
Right.
So let me just dwell on this concept, why this SDG has been so much the thing today. Responsible consumption, which means whatever is the carbon footprint which I'm expected to do as a matter of fact, because I'm running a production process, I have to be responsible in consuming the energy footprint for that particular process. The definition in the steam language is called as the specific steam consumption for that particular equipment.
Yes.
Now, that's where the SDG focuses on the responsible consumption to start with, because what we have to be mindful about is the economics of steam. If you can actually save 1 kilocalorie even of energy footprint requirement in that equipment, you have to then look at extrapolating the understanding to responsible production of utility, which is steam here, for that same process. So let me go and say that if I save 1 kilocalorie at an equipment level, and that's aligned to the SDG requirements, then I have the distribution losses. I had the energy which was used in the form of any fuel. So you said that it doesn't matter whether it's a fossil fuel or a greener fuel, a sustainable fuel. You are finally having a deficiency of conversion from the energy input to the steam generator to what you have generated steam at. So even if it's, let's say, about a 80% efficient steam generator, you are still looking at this efficiency, which is going to be a deficiency when you look at responsible production. And then you have the distribution losses. Typically, a process industry would have the distribution inefficiency of about 3 to 5% in the steam network. So if you look at now that 1 kilocalorie and try to extrapolate and backtrack it towards the responsible production part of SDG, you would understand that you have to actually, you can save 1.75 times more in the steam generation area, just by focusing on 1 kilocalorie here in the utilization area. And that's where sustainability has a very practical dimension.
Yeah.
And engineers have to play the crucial role of placing themselves accurately. Because what does happen in the practical scenario? In the practical scenario, when you look at any energy conservation as a drive, it needs financing, right?
Yes, correct.
Nothing is going to be free.
Right.
So you need to do something, and I'll come to the whole part of doing things a bit later. But if you have to do something to improve your carbon footprint, then you have to really get a finance approval for such a project.
Yeah.
And that's where engineers have to be now techno-commercial in their appearance. Gone are those days where I would say that a good engineer is good enough to really convince economists. Economics have also taken huge leaps and bounds, while engineering, you are saying, has also advanced. So people would look at, where should I invest my money? What gives me the return on investment?
Yeah, right.
And as an engineer who's working in the space of utility, you will have to be mindful about the economics of what I am trying to influence in the plant and how does it play against the carbon footprint.
Right.
I'll again give you a simple example to explain this point. If you have a steam system in a textile plant, let's take textiles because it's very easy to understand. Textiles typically have two processes where steam plays a very crucial role. One is dyeing, which means you dye the cloth, the raw fabric, and get these shades of colors. And then you have the drying process where you are actually looking at the resultant moisture before the cloth is actually reeled and then transported ahead. So that's where I would say that drying and dyeing are two processes in a textile plant which are very easy to comprehend. And if you had this process with this steam giving its latent heat to the process and condensate getting formed, if this condensate, which is hot water coming out of this equipment, is just recycled back,
Yeah, right.
this condensate has energy in the form of two forms. One is flash steam, and then you have the sensible heat in the hot water, which is condensate here. So this energy is close to about 80 to 20% in the overall network.
Right.
So just if a textile plant looking at this management of condensate, it would get a 12 to 14% reduction in carbon footprint. Now that's where I'm saying that you are actually supercharging your utility when you use steam as a utility.
Yeah.
That's something which is boosting up your capability to look at an increase in the resultant feed water temperature,
Right.
which gives you a higher steam to fuel ratio on the boilers.
Right.
So
Right.
these are so many advantages. We know the whole world is looking at water footprint.
Yeah, absolutely.
You're looking at a network in steam. If it is so closed loop, you are benefited because you have water which is coming back to the network. You don't have to look at fresh supply of water to the boilers. There is so much to it. And if you have condensate coming back, you're blowing down less.
Yeah.
All this is economics.
Right, right.
And that's where the engineer has to be mindful about what he's doing. You get those budgets, get that understanding of steam, because that is motivating to really feel good about the engagement in a topic which is relevant. Because as I said, it plays a crucial role in productivity and also in terms of process efficiencies. And second, it directly impacts the bottom line of the company.
Yeah.
So
Absolutely.
it's a win-win for all.
Yeah, absolutely. In fact, this is one of the areas where I think sustainability and economics actually go hand in hand.
Absolutely.
If you're looking at something like EVs or electric power, there you are actually looking at replacement. Replacement costs are often prohibitive,
Yes.
But in this context, it is actually something that goes hand in hand. Many of these also seem to be low-hanging fruits. When just sending the condensate back itself, it may require some infrastructure. But if we are talking about the CO2 savings and fuel savings to the tune that you spoke about, the payback would be negligible in that case.
It would give you a payback of less than a year.
Less than a year, which is very, very attractive.
Impactful for any process.
Everything subsequent to that is pure savings.
Absolutely.
And you're just fine-tuning the product. You're just fine-tuning the process without having to add anything excessive onto the system.
Right.
It is a very attractive proposition. Okay. And there are multiple things that can be done. This is just one example, I think, that you
Yes.
Yes. So, do you have any other areas? I mean, you could just list them down here.
Sure. So if you look at the whole steam network, and you look at again coming back to the point on SDG, we are saying that finally the fuel input for the steam network has to be a responsible SDG goal, which means it has to be viable to make it really competitive in the world. And that's where we are saying that the SDG specifications say that clean fuel at a viable cost. It is not, it cannot be prohibitive in nature. And once we look at the steam network, the conception which most engineers do carry is that our steam systems, open-ended systems, whereas, hot water systems, thermic fluid systems are closed loop systems, everything what you pump in the lines comes back. That conception is actually to be washed out. If that conception prevails, there is a misnomer in engineers that, then am I really playing with a utility which does not give back everything what I pumped in?
Correct.
That's where there is a huge upgradation in technology which is happening already. Like the world, we have to be mindful about that. There are already companies who are looking at waste to energy. That's one part, which means if you have a hot water which is coming out of the blowdown, so you have a wastage there. So I was just trying to look at your question and say that, how do you make it relevant to say that there is consumption which is happening at each point in the circuit, and how do you look at energy footprint? So if you have a boiler which is blowing down, you have hot water coming out of the blowdown line. There are technologies today to look at, how do you separate the flash steam, put it back into the feed water tank? How do you play with this hot condensate? Try to extract the heat using either a shell and tube or a plate heat exchanger. Try to reduce the temperature. It directly impacts the COD, VOD, because now you are having condensate, which is not good water because it's blow down water, it's contaminated water, now coming down at a temperature which is manageable. So you are directly impacting the carbon footprint because you are now having less of COD, VOD to handle in the effluent treatment area. You have this energy which is now available as input energy for heating up the feed water. If you just go ahead into the distribution part of the network, you would have so much to understand and empathize with in terms of looking at pressure drops, trying to address that concept, trying to understand if there is condensation which is happening in the pipelines, how do you recover this condensate from the main steam distribution lines back to the feed water tank. There's so many energy conservation projects, and the most important of that is at the utilization area, where you look at pressure controls, you look at temperature controls, you look at correct process steam trapping. Right. We should spend a certain amount of time looking at steam traps because they are not so famous as any of the Mission Impossible reels which are going around. So you would have to really look at the word steam trap and empathize with it, and not really try to say that I'm a steam engineer, but I don't know what is a steam trap. So